Hello to JCB viewers. Welcome to JCB EduBuild Solutions, founded by engineer James Bolo. Today, our discussion will be plumbing arithmetic. You have 2 hours to answer 100 questions. This is a high-stakes test of your mechanical recall and mathematical speed. This single subject carries a 10% aggregate weight on the board exam. A strong performance here creates a massive buffer for the other sections. To secure that 10%, we are mapping the most efficient route through the material. We start with algebraic shortcuts, bypass the time sinks, and allocate our heavy lifting to spatial geometry and trigonometry. You need a working knowledge of basic algebra, like work and mixture equations. However, these are often dense and time-consuming. Dedicating all your review hours here yields diminishing returns. Many of these concepts demand pure memorization. The clock problem formula is a perfect example. You plug in the angles, apply the constant, and extract the answer. Furthermore, you can completely bypass manual computation for a large portion of algebraic word problems involving two unknowns. By identifying linear equations and feeding the variables directly into your calculator's mode 5-1 function, you instantly output the points of intersection. No manual isolating, no substitution errors. Napapansin niyo ba? Sa basic algebra, formula and correct calculator mode lang ang katapat. Mastering these calculator techniques buys you the most invaluable resource on exam day, the time required to solve the spatial puzzles that form the core of the test. Geometry dictates the physical realities of plumbing. It is how you determine tank capacities, estimate trench volumes, and calculate pipe cross-sections. The exam tests spatial fluency with cones and complex triangles. In problem 7, given an altitude of 3 and volume of 36 pi, work backward to isolate the radius. For problem 8's triangle with unequal sides, 12, 16, and 21, use Heron's formula for the area. Ano ang gagawin natin dito kapag binigay ang slant height instead of altitude? A common pitfall is the diameter-radius mismatch. Exams frequently supply the diameter, assuming you'll rush past having it. If you plug the full diameter into pi r squared h, you generate a massively inflated volume, and that incorrect output is almost always waiting in the multiple choice options. The second major trap is unit conversion. Executing perfect math on square millimeters when the answer key demands square meters results in a 0. Always lock in your final units before starting the calculation. If gusto nyo ng mas maraming ganitong problems, especially sa trigonometry and geometry, message nyo lang kami. Meron kaming complete reviewers, videos, and practice exams ready. In these exercises, the difficulty isn't found in advanced theorems, but in the precision required for unit conversion and basic shape anatomy. Next is trigonometry. This is your primary tool for navigating pipe routing, establishing slopes, and calculating precise offsets in the field. Pipe routing is a direct application of right triangle geometry. These abstract concepts morph directly into physical installation measurements. The hypotenuse becomes your travel pipe. The adjacent and opposite sides represent your horizontal run and vertical set. When you know two sides of an offset but lack the angle, the Pythagorean theorem acts as your immediate backup to find the missing length. Let's apply this to a high-yield scenario, calculating travel length using a standard 45-degree fitting across a known run. Dividing the adjacent run by the cosine of 45 pinpoints the exact travel distance required. Dito madalas magkakamali ang marami, kaya i-step-by-step natin. The error happens during the reference angle shift. If measured from the vertical wall instead of the horizontal floor, opposite and adjacent sides swap. Applying cosine when geometry demands sine completely inverts your offset calculation, leaving your pipe out of alignment. By locking down the rules of the right triangle, you eliminate guesswork, turning physical pipe routing into a series of predictable calculations. Let's consolidate the math into your operational cheat sheet. In geometry, apply volume formulas for tank capacities and area formulas for cross-sections. In trigonometry, the right triangle calculates pipe offsets. Finally, always align your units and explicitly check for radius versus diameter. Kung may lalabas sa exam, malaki chance nandito sa dalawang ito. Passing this exam isn't about blind cramming. It requires a systematic strategy to identify the type of problem and apply the most efficient solution. Plumbing arithmetic is exactly like reading a schematic. Once you recognize the parameters and apply the core rules, the solution follows a fixed logic. Thank you, JCB viewers, for listening, and for those who are not yet following, please follow us for more contents and free reviewers for you. See you on the next topic.